Today I'll present our research, Inception Cloud, where we build a nested cloud architecture. This is joint work with my colleague Yu Mao. We're both from AT&T Labs Research. We know that everybody knows that infrastructure as a service cloud is good, right? As exemplified by Amazon EC2. However, with IaaS cloud, you cannot do many things. For example, VM live migration. I believe Amazon EC2 does not allow you to migrate VMs from this location to another, right? Why? This is not because Amazon guys do not know how to do this. Of course they know, especially given that these days technologies like KVM and Vm has mature technologies to do VM live migration. So we argue that they do not allow us to migrate VMs simply because there's a conflict of interest between users. Why? Because VM live migration typically requires VMs running on a shared storage over a layer 2 network, and which is typically more expensive than the layer 3 networks provided by cloud providers. So while some applications desire these live migration features for purpose like load balancing or others, some other applications like web hosting do not require these live migration features. So there is a conflict of interest between different users, and the cloud providers like Amazon has to make a trade-off between providing features like this versus the cost to realize it. And the similar cases include there are a bunch of similar cases, like to enable intrusion detection by customizing DOM0 firewall rules to provide high availability for VMs by replicate VMs in the cloud, and also to do VM instant spawning under high workload. So you can do none of this in current IaaS cloud. Why? Because you do not control the hypervisors of underlying physical machines. They're controlled by cloud providers, and they are not willing to provide these features to us regular users. As cloud researchers, you may want to build your own large-scale cloud, right? We want to do this. Especially, we want to make our cloud even more fancier by running it across multiple data centers over a wide area. Especially given that these days, open source solutions like OpenStack and CloudStack become increasingly popular. However, the answer is still no, you cannot do this. Why? Because only mega-sized companies like Amazon, Microsoft, and Rackspace are able to do this. This involves, first, a huge amount of money, investment to buy physical machines, to deal with real estate issues, running multiple data centers, and among other things. And also, you need to hire people to build and run this large-scale cloud, right? So we cannot. There are prohibitively high cost preventing us from running this large-scale cloud. So now that we have these VMs, these on-demand, seems infinite VM resources and other virtual resources provided by cloud providers, what kind of interesting stuff we can do with these VMs and virtual resources? So one idea is that why do we have to use VMs as just VMs? Why don't we just use them as physical machines? So the idea here is straightforward, which is that we're going to build and run nested cloud within the cloud provided by the cloud providers, and we're going to run virtualized environment within virtualized environment. And it turns out that this is quite similar to this. This scenario is quite similar to what is shown in this movie called Inception. Just wonder how many of you have seen this movie before? Okay, I guess most of you. For those of you who haven't seen this movie before, those guys in the picture, they create virtualized environment within virtualized environment. In other words, dream, and they bring the target into this virtualized environment and plant an idea in the target's mind and let the idea grow. So the whole process is called inception. As this figure shows, in the virtualized environment, they can do arbitrary things like to turn the city of Paris upside down, etc., etc. So it's really cool, I think. And one of my favorite quotes from this movie is that they say, "Downward is the only way forward," which matches exactly what we are doing here in our work, named Inception Cloud. So to build and run your own Inception Cloud, you get huge amount of benefits. This include, first, you can enable whatever fancy or great hypervisor flexibility in Inception Cloud. For example, you can enable you can do VM live migration, provide high availability to your VMs by replicate the VM instances, to do instant spawning under high workload, to conduct intrusion detection by customized DOM0 firewall rules. And in addition, you can do other fancy things like application-specific resource allocation by, for example, customize subscription ratios. For example, you can lower this ratio between VMs and and underlying hosts, such that your VMs can better serve performance-critical applications, or you can increase this ratio when most of your VMs are idling. You can consolidate your VMs onto less underlying hosts, such that you can reduce the cost of running a cloud. You can even do more. You can get more benefits because you do not deal with any physical metals in Inception Cloud. Deal with VMs, right? There's no issues to worry about, such as cooling, power, cabling, rack design, to replace malfunction, hardware, real estate, complicated issues. Well, in data centers, we just leave this boring stuff to cloud providers, and we researchers deal with all fancy, interesting research ideas on our Inception Cloud. To make it even more interesting, we can run Inception Cloud across multiple providers over geographically wide area. You can run your cloud spanning across both private and public clouds. There's no problem. And the takeaway point of this slide is that by running Inception Cloud, you get entire control of your cloud with even less operation overhead to worry about. So to make it more concrete, I will list a few application scenarios here. So suppose in the United States, you have two public cloud providers, one on the East Coast and one on the West Coast, and you have a third private cloud providers. And the first, for example, you can run web hosting Inception clouds. So suppose you have multiple websites to operate, and you can run one web hosting Inception cloud for each of your website. You can selectively enable hypervisor features like to do instant VM spawning, replication for high availability, intrusion detection by customizing DOM0 firewall rules, etc. And you can even optimize each of your web hosting cloud based on the workload characteristics of your website. The second example involves doing continuous integration. So continuous integration here means to test and debug your open source, maybe not open source, your cloud platforms to find potential problems. As this figure shows, you can run multiple continuous integration clouds on both private and public clouds. You can conduct comprehensive tests of your cloud platforms with full functioning network features. One of the coolest things with this continuous integration Inception Cloud is that when you are done with testing and debugging, you can simply throw away your Inception Cloud by simply destroy the underlying VMs. You have a very easy cleanup. And the third example is even more interesting. You can run virtual desktop Inception clouds across all three public and private cloud. For example, you can enable VM live migration features when you, say, fly from East Coast to West Coast to attend a conference like HotCloud, like me here. The virtual desktop VM, your virtual desktop VM will be automatically migrated from the East Coast to West Coast so that they can better serve you by providing better latency performance. You can even enable more features like do VM consolidation, to run a virus scanner at dump 0. There's no problem. We note that none of above scenarios is achievable in current infrastructure as a service cloud. However, Inception clouds enable you to achieve all of this. So next, let's take a closer look at the design and the implementation of our Inception cloud. For the cloud to realize Inception cloud, we're going to use OpenStack as our cloud management software. These days, OpenStack turned out to be the most popular hot open source cloud platforms for both private and public cloud for enterprises to build both private and public clouds. And our target is that we can run stock OpenStack platform without any modifications to its source code in Inception Cloud. And for hypervisor, we're going to use KVM with nested virtualization enabled. And we're going to design and implement the network component for Inception. And to differentiate, there are two types of VMs. For the rest of the talk, there are two types of VMs. The first one is reality VM. We call it RVM. This is just the regular VM, normal VM you get from, say, Amazon or Rackspace. We assume that each of them have a private IP address and one optional public IP address. And the second type of VM, we call it Inception VM, IVM. This is a VM. This is a nested VM running inside RVM, and we're going to build layer 2 networking to interconnect these IVMs. Why layer 2? Because we believe layer 2 is easy to configure and manage than layer 3, and is familiar by most network administrators. And just plug the instance in the network, and everything works outside the box. And one additional thing is that layer 2 enables us to do VM live migration. So for the rest of this talk, I'm going to focus on the network design and implementation in Inception Cloud. Why? Because it turned out to be the most important component to enable Inception Cloud. And we note that our design is independent of any underlying cloud service providers. So here is the overview of our network design. Suppose you have one data center, first data center, and you first get a bunch of RVMs, regular VMs from your cloud providers, either private or public, doesn't matter. So the RVM has an interface ETH0 provided by cloud providers inherently, right? And this is usually what you get from EC2 or Rackspace. And we're going to use ETH0 as a management interface in Inception Cloud, and we're going to build virtualized layer 2 network on top of this ETH0 interface and our network. The tools we use include software switch, Open vSwitch here, and also tunneling protocols, VXLAN here, to build virtualize the layer 2 network. We first build a ETH1, we call it private network. Basically, this ETH1 network provides private communication between IVMs, and IVMs inside these RVMs are plugged into the ETH1 network. The OBR1 bridge is the bridge, as shown in the figure, is created by software switch, Open vSwitch here. It's just a logical view, just a giant logical bridge connecting to all the ETH1s on the RVMs. In addition, we create a second virtualized layer 2 network, ETH2, which provides public internet access for IVMs. We note that these three sets of networks are isolated with each other, so things like eavesdropping is eliminated by design. And these three sets of networks are transparent to IVMs running inside RVMs. Suppose we have additional data centers like this one. We just need to create some gateway RVMs to build extra tunnels between data centers to provide inter-data center connections. So this is the overview design of our network in Inception Cloud. And the next, let's take a deeper look into the First, in the private network design. So this figure shows the design from the perspective of a single RVM. So basically, it has the ETH1, which is a private network. It's plugged into the OBR1. It's a localized software switch created by OpenVSwitch. And inside it, OpenStack is going to create additional bridge. BR1 is a Linux-based bridge, and plug all IVM's interfaces into BR1. There are several reasons why we need two bridges, right? OBR1 created by OpenVSwitch and BR1 created by Linux. And the first two are design reasons. Because OBR1, the OpenVSwitch switch, is out of a band for OpenStack network controller and is incompatible with Linux-based bridge networks used by OpenStack. Because we want to run stock OpenStack, right, without any modifications to the code. So we just want to make it as compatible as we can. The third reason is a technical one, because OpenVSwitch does not well support IP tables or EB table firewall rules. Next is public network design. Actually, providing public internet access to IVMs is quite challenging, given that OpenStack uses this technique called floating IP. Basically, it conducts network address translation between public IP and private IPs on VMs. So this figure looks a bit complicated, and I'm going to omit the details actually. But the basic idea is that the basic thing, it shows that we have two RVMs, RVM1 and RVM2 on the right, and RVM1 has a public IP 56.0.0.11. We can forward the traffic by manipulating the rules like DNet rules, SNet rules, source routing rules. We can forward the traffic to the IP 56 to the IVMs running inside another RVMs. So it looks like that the public IP is associated on the IVM running on another RVM. And this design enables that each RVM can host many IVMs with any number of floating IPs. There's no problem. And you can even migrate IVMs from one RVM to another RVM without disrupting any ongoing traffic between the internet and the IVM inside. And one of the fancy things is that this design even supports recursively nested Inception Cloud, which means that you can run Inception Cloud within Inception Cloud within Inception Cloud, as long as it is within the limit of your physical machines. So we have implemented a prototype of Inception Cloud, which can deploy OpenStack core components, like including compute, storage, and network component. And we use a tool called Chef to automate the process of deploying OpenStack and OpenVSwitch. So the whole process is automatically performed, and the source code is available at this link. Basically, we use OpenStack infrastructure to host our project, including doing code review, Git repository, and also testing environment. We have a deployment on our private cloud, and we can launch an Inception Cloud in about 20 minutes. So the final effect is that you just click a button, and after 20 minutes, you get a real cloud so that you can play with. You can research and experiment all kinds of interesting research ideas on your own cloud. Here I list a few of our ongoing work. There are several dimensions. The first one is performance. There are papers reporting that for the CPU and memory, the overhead is within 5 to 10%, which is pretty marginal, according to me. And however, we do notice some significant performance degradation on network and storage, and we are currently investigating the bottlenecks in I/O. The second dimension of our work is that we want to make the virtualized layer 2 network in Inception Cloud much more scalable. Our target is that Inception Cloud can run spanning across multiple data centers. Each data center can host about 10,000 IVMs. As you may know, conventional layer 2 does not scale to this size, right? So we want to use an approach with SDN-based control plan. We want to build SDN controllers to handle issues like ARP, DHCP broadcast, live migration, security groups, these issues, these non-scalable issues in conventional layer 2 networks. And another dimension of our work is that we are currently facilitate the continuous integration process in OpenStack. We use Inception Cloud to run OpenStack. We debug, we test, we experiment new hypervisor features, and we also experiment different kinds of resource scheduling and optimization algorithms we implemented in OpenStack. So go back to the movie. Miss Cobb says that an idea is like a virus, resilient, highly contagious, and even the smallest state of an idea can grow. It can grow to define or destroy you. And we hope that our idea of Inception Cloud has already inceptioned all of you. With that, my talk concludes here. And thank you, and I will welcome any questions. Thank you. Yeah, currently in VXLAN's implementation, multicast and broadcast is implemented as multiple unicast. And currently, this way does not scale, right? And we are like this scalable virtualized layer 2 networking. We are using SDN-based control plan to make it scalable.
Hi, Srikant Kandla, Microsoft Research. I'm just curious about your 5 to 10% performance overhead number.
Yeah.
Did you do any of the multi-memory paging and stuff like that the Turtles guys did to pull off such numbers? And what were your benchmarks?
These 5 to 10% numbers are reported by various papers. It's not. We didn't. We did similar experiment to measure these numbers, but it's consistent with the numbers reported by several existing publications, and we didn't do any customized. We didn't do any customization to KVM. We just use it to run our Inception Cloud. Does that answer your question?
So you're saying just KVM gave you those numbers?
Yes, this number is reported by the Turtles project by IBM guys, and also there are some other papers do the measurement. This is numbers they reported.
We have time for one more question.
Sure.
You can try to speak louder.
Yeah, thank you.
As we said, University of Lisbon. If I have a bunch of machines from Amazon EC2 and a bunch of machines on Rackspace, for example, would it be possible to deploy this solution?
Yes.
If not, what? Yes?
I think the answer is yes.
Okay.
Yeah. That is also one of our goal, which enables Inception Cloud to span across multiple different cloud providers across wide area. Currently, Rackspace runs OpenStack. By default, the nested virtualization is enabled. So I think there's no problem to run it. And for Amazon, they use Zen. By default, it does not support nested virtualization. However, you can use tools like Zen Blanket. It's a Eurosys paper, and they have source released. You can enable nested virtualization run on Amazon EC2. So I believe there's no big problems for this thing to run across both Amazon and the Rackspace.
Thank you very much.
Thank you.